Find the x and y intercepts and the vertical, horizontal, or slant asymptotes. If there are multiple of a specific intercept or asymptote, list them in order from least to greatest. If there is none, enter D and E. Alright, so I have the function f of x equals 3x minus 5 over x minus 1. The location of x-intercepts for any function happen whenever the function itself is equal to 0. And when it comes to rational functions, it's where the numerator is equal to 0. And it's really just the numerator that we are concerned with. So we take 3x minus 5, set that to 0, and so that gives me 3x equals 5, or x equals 5/3. Now that's just the x-coordinate of the x-intercept. The y-coordinate is, of course, 0. So 5/3 and 0. The y-intercept, if it's in factored form, you just take the ratio of the constant terms, because essentially what you're doing is to get the y-intercept, you're letting x equal to 0 and solve. So when you let x be 0, both of these terms go to 0, and you're just left with the ratio of constant terms. So the y value here is going to be -5 over -1, which is +5. So the y-intercept occurs at the point 0, 5. Horizontal asymptotes. We have some rules for horizontal asymptotes, and you get those rules by comparing the degrees of the numerator and denominator. If the degrees of the numerator and denominator are the same, which they are in this case, they're both equal to 1, you take the ratio of the leading term coefficients. So here I'm going to take the ratio of 3 and 1, so I get y equals 3 as my horizontal asymptote. If I have a horizontal asymptote, that rules out the possibility of a slant asymptote, so that's not going to happen. That does not exist. You can't have both a horizontal and a slant asymptote. Vertical asymptotes. Vertical asymptotes occur whenever the denominator is equal to 0. So the denominator is equal to 0. So essentially similar to the concept of the x-intercept, these are zeros of the numerator. Vertical asymptotes are just zeros of the denominator. So we just take the denominator, x minus 1, set that equal to 0, and solve. So at x equals +1, we have a vertical asymptote. And here, this is the equation of a vertical line. So I do just leave it in the form of an equation for a vertical line.